So last week we have covered the basic arithmetic operations regarding the square matrices, and we found that square matrices can be actually the set of close to the four basic arithmetic operations on some particular conditions that specific form of the matrix is not zero. On the condition that some quantity which we are going to call determinant to be defined later is non-zero on the condition that a quantity, a particular quantity, is non-zero. For example, for 2 by 2 matrices, matrix A, A11, A12, A21, A22, if A11, A22 minus A12, A21 is non-zero, then we can define inverse matrix, which actually corresponding to the division of matrices. Divide by A11, A22 minus A12, A21, A22, A21 minus A12 minus A21. So inverse matrix can be like operand for the division. So in comparison, for example, if the matrix A divided by B, let's say some matrix B divided by A, so actually can be defined as B times A inverse, A inverse B. So division can be defined. The matrix division can be defined the following way. So last week I posted my class on the YouTube. Anybody has checked my class? Raise your hand. Okay. Some of you have checked my class, right? And actually there are maybe 4 or 5 years of my class in the YouTube. You can find my previous lectures and maybe you can use it to preview. Okay. So this particular quantity, when we define A as A11, A12, A21, A22, this is a 2 by 2 square matrix. So about 70% of the time, so we are going to play with just 2 by 2 matrices, which is easier. But while you can learn the basic concept of matrix operations. But occasionally we are going to expand into like 3 by 3, maybe sometimes 4 by 4, especially for the quiz or homework, but that would be exceptional occasions. So we call this A, particular quantity A, as a determinant of A. So sometimes we call determinant of A, or A. So there are two ways of writing determinant. One is specify determinant, like in the first place, or absolute value of A. So determinant is actually, you can regard a function that assigns a number to a square matrix. So if we define N as a set of square matrices, and this is a set of real number, then determinant A can be defined as a function to R. A belongs to N. So we can actually define determinant as a function that assigns a number to a particular square matrix. And perhaps we can just write down in a symbolic form that this N tilde is a set of square matrices, and we assign number to each matrix. So that is basically a rule. So 2 by 2 matrix is a very simple rule. So the question is, can you define determinant for higher dimensional matrices like 3 by 3? The next question is, how can you define determinant for a matrix larger than 2 by 2? That would be the natural question, right? So I define determinant for 2 by 2 and also define the inverse matrix. But is there a way that we can extend this definition to the higher dimensional matrix, the larger dimensional matrices like 3 by 3 or 4 by 4? So that's the topic that we are going to cover today. And in order to do that, we need one more concept, the transpose operation. The transpose of a matrix is basically exchange of row and columns. columns. For example, if A is 1, 2, 3, 4, transpose is defined as the first column become first row. So 1, 3. Second column becomes second row, 2, 4. Or you can regard this as the first row become first column. Same, right? Second row becomes second column. So anyway, you exchange a particular row with a particular column, or vice versa. Symbolically, if we can write down A as component form, Ij, A transpose is Ij's component of transpose matrix is Aj. You just interchange the index for the row and column. Actually, trans is a prefix for Latin. Meaning across. So, for example, transcontinental. So somehow mathematics class become English class. Transcontinental. That means across the continent. Trans-Pacific. Trans-Pacific means across the Pacific Ocean, right? Or for Europeans, transatlantic, like across the Atlantic Ocean. Transpose. You have a pose, you just change, right? So transpose. Pose is a pose, like a form. Trans, across the form. You just interchange the form. Or transplant. You interchange the plant, right? Something like that. So this is maybe easier way to remember if you are interested in taking TOEIC class, TOEIC exam, or TOEFL, whatever. Anyway, it's a side story. Something you can learn along with the mathematics. So transpose is just interchange the particular column with a particular row. What happens if we multiply two matrices? If we multiply A times B and take a transpose, the same as the transpose of B times transpose of A. Ij's component of AB is you sum AI K A K J, right? B, sorry. Transpose. You take a transpose and take the Ij's component, then it's same as A times B times JI. JI components, right? So sum of k equal to 1 to n AJK BIK, right? Oh, sorry, KI, right? Same as BIK trans. Oh, sorry. PKI is actually B transpose IK, right? And AJK is A transpose KJ. So it can be written as BT AT IJ. So component-wise, we can easily show that the multiplication of these two becomes A transpose of AB is same as B transpose times A transpose. Maybe a little bit too abstract. So if you think I'm going too fast, maybe you can raise your hand or maybe ask some questions or whatever to make me slow down. So let's some particular examples. A 1, 2, 3, 4. B 5, 6, 7, 8. A times B 1, 2, 3, 4, 5, 6, 7, 8. You can do it with just using memory. 5 times 19 is 14, 19, right? 5 plus 19, second row, 6 plus 16 is 22. $15 plus 28, 43, right? Finally, 18 plus 32, 50. So AB transpose is very simple. 16, 43, 22, 50, right? How about B transpose? 5, 7, 6, 8, right? A transpose 1, 3, 2, 4. If we multiply BT times AT is 5, 7, 6, 8, 1, 3, 2, 4. First, five plus 14 is 19. $15 plus 28, 43. 6 plus 16 is 22. Last one, 18, 32, 50, right? So you can see that so it turns out that this and this are the same, right? So you pretty multiply A by B and take a transpose, it's the same as you multiply the transpose of B times transpose of A. So you can actually elegantly prove that this property using the formal method, but also you can see that by particular example. So we have enough tools to define determinant for larger than 3 by 3. Minor. Matrix by obtained is obtained by deleting a particular row and column. So for example, Mij is a determinant of a submatrix obtained by deleting ith row and jth column. And for 1 by 1 matrix, a determinant is same as the number itself. For example, we can define just 1 by 1 matrix, right? Say A. So 1 by 1 matrix is actually the same as the number. And determinant is defined by that number. So in that case, if A is A, determinant A is A. So let's go back to the 2 by 2 matrices. A11, A12, A21, A22. So determinant M11. Determinant M11 is M1 minor M11 is a determinant of a matrix obtained by deleting the first row and first column, right? So deleting this and this, right? So in that case, A11 is A22. How about M12? M12, you delete the first column, the first row, second column, A21. M21, you delete the second row, first column, A12, M22, A11. So this is minor. And also we define cofactor. Cij define the minus into I plus 2 Mij. The cofactor is defined by minus 1 to the I plus j times Mij. So C11 is minus 1 to the 1 plus 1 M11, right? So same as minus 1 to the 1 plus 1 is just 1, right? So this is A22. C12 minus 1 to the 1 plus 2 M12 is minus 1 to the 1 plus 2 is minus A21. C21 is minus 1 to the 2 plus 1. M21 is minus A12. Oh. C22 minus 1 to the 2 plus 2. M22 is MA11. This is cofactor. Minor is defined by following this way. Am I going too fast? So in half an hour, I introduced the concept of determinant, transpose, minor, and cofactor. So you have to digest these 4 concepts at least during this class. Other than that, it's basically algebra. So nothing that too difficult, I hope. So let's try with a 2 by 2. And we have cofactor. C11 is A22. C12 is minus A21. C21 is minus A12. C22 is A11. Let's make some simple summation. K equal to 1 to 2. A1K, C1K. What happens? Just simple 2 summations, right? So this is A11, C11, A12, C12, right? So this is A11, A12, A22 plus A12. C12 is minus A21, right? So A11, A22 minus A12, A21, which is determinant A, right? How about this? A2K, C2K. A21, C21, C21, A22, C22, which is A21 minus A12, A22, C11. This is again determinant A, right? How about if we interchange the order? AK1, CK1. A11, C11 plus A21, C21. A11, A22, A21 minus A12 is again determinant A, right? How about the other one? AK2, CK2. A12, C12 plus A22, C22, which is minus A12, A21 plus A22, A11 is again determinant A, right? So cofactor is somehow related to the definition of determinant, right? So can I move on to the next page? Enough time? So we have one conclusion that at least for 2 by 2, Aij, Cij is determinant A, right? Or J is equal to 1 to 2, Aij, Cij, right? What about if this case, A1K, C2K, what happens? If the row index are different, what will happen? Let's check. A11, C21 plus A12, C22, right? A11 minus A12, A12, A11, which is 0, right? Or AK1, CK2. case, A11 C12 plus A21 C22. A11 minus A21 plus A21 A11, right? Again, 0. So the element of the matrix and the cofactor matrix is a very interesting property that to 2 ik cjk is determinant A over 0 when I equal to j different, right? Or same AKI CKJ, same result. I equal j 0 different, right? So this is a very important property. And I'm going to introduce one particular function. Right. Kronecker delta. It has a name. Kronecker delta is so when the subscript are the same, they are 1. But the two indices at the subscript are different, they are 0. Oh, some more English class. If we have A, this is called superscript. This is called subscript. I guess everybody knows that. So script is actually Greek, means word. The super is up, sub is down, right? So 지하철 is called subway, right? Sub is under, super is up. So superscript means the word in the upside. Subscript means the word in the downside. And Holy Script, Bible, right? So everything comes from Greek word script, word. So using this index, we can say that AIK CJK AKJ, let me see, CKI delta IJ. And the matrix C is called cofactor matrix. Cij, right? C11, C12, C21, C22. Transpose of cofactor matrix C11, C21, C12, C22 is A22 minus A12 minus A21, A11. Then when determinant A is non-zero, then inverse matrix is defined as 1 over A transpose of cofactor matrix. It is defined for 2 by 2, but it's generally true for n by n. But we haven't defined the determinant for 3 by 3 or 4 by 4. So there are two ways of defining determinants. One is this, and the other one is inverse matrix. There's two formulas that you need to learn, I hope, during this class. So we have a basic knowledge for how to calculate the determinant for any dimension of matrices. Any questions? Actually, you can ask me a question in Korean too. I mean, even though this class is supposed to be, the official language of this class is supposed to be in English, but just in case, if you're not comfortable speaking English, you can ask me a question in Korean. No questions? All right. Perhaps you can take a break for a few minutes and continue with the 3 by 3 matrices. Okay, let's continue with the discussion. Another property is product of the determinant is same as the determinant A times determinant B. So say A 1, 2, 3, 4, 5, 6, 7, 8. A times B is 19, 22, 43, 50, right? So probably by now you should be able to do it by just your memory. So determinant AB 19 times 50 minus 22 times 43. So bit of algebra, 19, 50, right? Eighty-six, 49, 46. Is 4, right? Determinant A, 4 minus 6 is minus 2. Determinant B is 40 minus 42 is minus 2. So A times B is again minus 2 times minus 2 is 4. So you can see that by example. But that can be for particular cases. So what we need to do is to actually calculate when A is A11, A12, A21, A22, B is B11, B12, B21, B22. Determinant A is A11, A22 minus A12, A21, right? Determinant of B is B11, B22 minus B12, B21. If you multiply A by B, it can be a little bit complicated, right? A times B, A11, A12, A21, A22, B11, B12, B21, B22. So you need a little bit of patience. The first element, A11, B11 plus A12, B21, right? Second element, this, A11, B12 plus A12, B22. This and this. A21, B11 plus A22, B21. Finally, A21, B12, A22, B22, right? So determinant of A is, you can just do it by multiply this, and this, subtract this, right? So A11, B11 plus A12, B21 times A21, B12, A22, B22 minus A11, B12, A12, B22 times A21, B11, A22, B21. So how many elements do we have? Just simply 4, 8. So I'm going to try to make a copy. No. Not this one. Oops. Which one is which one? This. not this one. Okay. How to make a copy? Uh-oh. Okay, let's try to make a copy. Copy. And delete. Let's see if it works. Paste. Okay, nice. So I don't have to write it again, right? So, what do we do? It's only 8 elements, so you just need to be patient. Of course, there are other mathematical methods, but I'm just going to be the brutal force. So first one, A11, P11, A21, P12, plus Y, it becomes A12, P21, A21, P12, plus A11, P11, A22, P22, plus A12, P21, A22, P22, minus A11, P12, A21, P11, minus A11, P12, A22, P21, minus A12, P22, A21, P11, minus A12, P22, A22, P21. So let's try to form some combinations. This A11, P22, this. See what happens. A11, A22, P11, P22 minus P12, P21, right? Now let's try to find something like this. A1 to A21, A1 to A21, A1 to A21, this. A1 to A21, P12, P21 minus A11, P11, P22. The other components, let's check. A11, P11. This one, A11, P11, A11, P11. We have A21, A21, P12, right? So they cancel each other. A12, A22, this one, and this one. A12, A12, A22, B22, A. So this cancels each other, right? So it turns out that A11, A22 minus A12, A21 times B11, B22, B12, B21, right? So this turns out to be determinant B. So I'm just going to show that only for 2 by 2, but you can easily, I mean, it's generally true. So in general, determinant of A, B, determinant A, determinant B. So this is probably the very nice timing to give you homework that I'll just let you copy. This way. This is your homework. A equal A11, A12, A21, A22, B, B11, B12, B21, B22, C, C11, C12, C21, C22. Show that determinant A, B, C, A, B, C. I think it may take about, you have 16 elements, right? No, 8 times 4, 32 elements. So I think it will take about approximately 1 hour. So if you can show this following the method I have done the previous, so if you can show this property in 1 hour, you are in good shape. And this is for your homework, means do it home, but you don't have to submit. So it takes about 1 hour. 1 hour, maybe. If you're really, really good, maybe half an hour. So this is supposed to be a joke, but the best time for doing homework is during your blind date. 소개팅. So you are sitting, you arrive at the place, but your partner didn't show up, right? So what do? Do your homework, right? So if your partner, your supposed partner doesn't show up, even after you finish your homework, what do? You just go home, right? So doing your homework. You have coffee. Homework for when you stood up. Stood up means 바람 맞다. It's the best time for doing homework. But don't worry, you will get a good grade. right? If you do the homework. It's supposed to be a joke. So let's go back to the 3 by 3 determinant. Maybe before I proceed to class, I can give you one very nice joke. It could be, is there anyone who has a German origin? No? It's about German engineer. So Peter and Hans are German engineers, very good German engineers. And Peter is traveling around the world, collect a good joke. So one day he flew to the America and went to the bar in New York, and he asked the bartender that he knows any good jokes. So, okay, the bartender was thinking about a little bit, and then he gave one very simple joke. Here is one. How many sausages can you have on an empty stomach? How many can you have on an empty stomach? So Peter is a really good engineer, so he put out his calculator and numbers. So divide by the volume of his stomach by the volume of the sausage, and he said 5.3. And the bartender says, no. After one, your stomach is no longer empty, right? If you already have one sausage, then your stomach is no longer empty, right? So Peter thought it's a really good joke. So he went back to Germany, and he told his friend Hans, okay, here goes one. I got a really good joke from America that is following, that how many sausages can you have on an empty stomach? Hans is also a good engineer. He put out his calculators and then, 4.3, because he has a smaller stomach. Then, no. If your answer was 5.7, I could give you a good joke. You're supposed to laugh. Both engineers don't understand that after one sausage, your stomach is no longer empty. But Peter thought that then the number has to be precise. So it has to be 5.7. Right? He didn't understand the joke. No. Okay, maybe next time. So I have a few more stories about that bartender, so maybe next time. Three by three determinant. So matrix A. A11, A12, A13, A21, A22, A23, A31, A32, A33. The formula is the same. Determinant A is now K is equal to 1, 2, 3, A1K, C1K. So you need to have three cofactors, right? So that means A11, C11, A12, C12, A13, C13. So cofactor matrix C11 is minus 1 to the 1 plus 1, M11. So M11 is a matrix that obtained by deleting the first matrix column and the first row and first column, right? So this is M11. determinant of A22, A23, A32, A33. So this turns out to be A22, A33 minus A23, A32. C12 is minus 1 to the 1 plus 2. M12 is minus 1 to the 1 plus 2 is minus, right? So it's minus times M12 is you delete the first row, first column, this. So A21, A23, A31, A33. So this is minus of A21, A33 minus A23, A31. C13 minus 1 to the 1 plus 3, M13. So minus 1 to the 1 plus 3 is plus 1, right? And you delete the first row, third column, you get this. A21, A22, A31, A32, A21, A32, minus A22, A31. So determinant A finally A11, A22, A33 minus A23, A32 plus A12. You have minus, so I'm going to put the minus sign. Minus A21, A32 minus A23, A31. Let me see. A3, no, A3, A33 plus A13, A21, A32 minus A22, A31. Again, I can do copy, delete. Next page. Can I move on to next page? I think I'm getting a little bit fast. I think I made it right. Let me just try it again. Just make a copy. I made a copy. And delete. What happened? Uh-oh. Page? Okay, paste. Next, so I can move this. Right. So we can just rearrange that. Let's put the plus sign together and minus sign together. A11, A22, A33 plus A12, A23, A31, A13, A21, A32 minus A11, A23, A32 minus A12, A21, A33 minus A13, A22, A31. Look at the, okay, I'll enlarge a little bit. Okay. So I arranged the terms such that the first index is 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So I arrange the terms that the root of row is always 1, 2, 3. And let's try to look at the column index and see what happens. So this is 1, 2, 3, right? 2, 3, 1. 3, 1, 2. Can you see some correlations? 1, 2, 3. 1, 2, 3. 2, 3, 1. 3, 1, 2. How is this 1, 2, 3 arranged? Can you see some kind of permutation? 1, 2, 3. 2, 3, 1. 3, 1, 2. How they arranged? In that case, this is 1, 2, 3, counterclockwise, right? So 1, 2, 3. What's that? Or 2, 3, 1, right? 3, 1, 2. We call this even permutation. If 1, 2, 3 are arranged in counterclockwise, we call this as an even permutation. How about the other one? 1, 3, 2. 2, 1, 3. 3, 2, 1. In that case, the red ones, 1, 2, 3, arranged in clockwise, right? In that case, 1, 2, 3 are arranged in this way. First one, 1, 3, 2, right? 1, 3, 2. 2, 1, 3. 3, 2, 1, right? So this is called even permutation. So this can be put together into one simple notation that epsilon ijk even permutation. One minus one. Sorry, maybe I should. epsilon I j k defined as 1 minus 1 0 I j k and even permutation. Of course, I j k is 1 to 3. I equal j equal different odd permutation. Otherwise, this is a particular name called the Levi-Civita. Symbol. So you learn two exotic functions, Kronecker delta and Levi-Civita. Then determinants can be defined as the following. Epsilon I j k you may have several mental blocks today. Kronecker delta and Levi-Civita. You have to be able to understand what is even permutation of 1 to 3 and odd permutation of 1 to 3. Even permutation is when 1 to 3 are arranged in counterclockwise. 1 to 3, 2, 3, 1, or 3, 1, 2. Odd permutation is clockwise. 1, 3, 2, 3, 2, 1, 2, 1, 3. So even permutation means one, two, three, 2, 3, 1, 3, 1, 2, right? Odd permutation 1, 3, 2, 3, 2, 1, 2, 1, 3. So those are the odd permutations. So there are 6 elements for the determinant A for 3 by 3 matrices, and they can be together in one simple form. If you understand this Levi-Civita symbol, then am I loud enough? Can you hear me where? In the back? So 3 by 3 determinant is usually the first, the mental block for this semester. But if you can overcome this, then the rest are not that difficult. So yes? You mean the red one? Yes. So our communication has a minus sign.
저희 빨간색 되는 거예요. 이분 퍼뮤테이션, 그러니까 오드 퍼뮤테이션인데 이분이라고 써 있어.
Sorry. Yeah. It has to be odd. Sorry about that. Odd. So 3 by 3 determinant has 6 elements, and 3 are positive, and the other 3 are negative. And the positive elements are with the even permutation, and the three negative elements are with the odd permutation. But actually, this concept is a bit too abstract, right? I guess. So I will give you one practical method that works for 3 by 3. But I will give you enough time to copy. So if you have any difficulty following me so far, raise your hand. I can probably repeat it again. Or can you follow me? I hope. So one practical method is actually with this even and odd permutation concept that when A, okay, let's start with the blue. A is A11, A12, A13, A21, A22, A23, A31, A32, A33. So determinant A is actually the even permutation is this way. This is arrow. The even permutation is A11, A22, A33 plus A21 A13, A21, A32 plus A12, A23, A31. Now you can check. 1, 2, 3, right? 3, 1, 2. So this is 1, 2, 3, clockwise. 3, 1, 2. 2, 3, 1, right? So this is even permutation. Odd permutation is, let me see. Other colors, let me see. Custom palette, let me see. Plus. This, okay, orange. Done. Okay. Odd permutation is this way. This and this. So this is odd. This is even. So minus A13, A22, A31 minus A11, A23, A32 minus A12, A21, A3, 3. So let's check. 3, 2, 1, right? That's odd. 1, 2, 3. Clockwise. 3, 2, 1. 1, 3, 2, right? This is again odd. 2, 1, 3. 2, 1, 3 is again odd. So this is practical method of calculating the determinant. So you can either use cofactor method or multiply by this. So let's put some numbers. So there are three methods. One is using cofactors, right? Cofactors. Secondly, you can use Lewis-Vector. Thirdly, this brutal method. So you can choose whatever the matrix you like, whatever method. In this case, the first row contains two zeros, right? So which method will be most convenient to this case? Either way, you can use the brutal method, right? With two zeros. The Lewis-Vector is always next, the last zero, which is very conceptually difficult, but easy to program. So how many of you can write program in Python? See? You didn't learn any computer language? Python or C? Okay, good. So if you're familiar, fluent in, Python, you can very easily write maybe 10-line program to calculate the determinant using the Lewis-Vector symbol, because you just define the function, the external function, right? Just calculate the cases. And if the three variables are all different, and then if you can check then maybe 10 line will be enough. In that case, you can use a cofactor method, because you can just put A11, C11. And delete the first row, first column, and this is determinant, right? So this is basically just 1 times 3, 4, 6, 7. 21 minus 24 minus 3. Right, very easy. Maybe good time for homework. 1, 2, 3, 4, 5, 6, 7, 8, 9. Find A. Maybe one more. 9, 8, 7, 6, 5, 4, 3, 2, 1. Find B. If you have bigger matrix larger than 3 by 3, say A11, A12, A13, A14, A21, A22, A23, A24, A31, A32, A33, A34, A41, A42, A43, A44. In that case, you can use two methods. One is four-factor. The four-factor matrix, then you have to do it again. 3 by 3 determinant, and then you have to reduce the 3 by 3 into 2. If you are fluent in Python, however, you can just write down this way. Epsilon I j k l 1i, a2j, a3k, a4l, I equal j k l. So it's a generalized Levi-Civita. Epsilon I j k l is same. 1 minus 1 0. I j k l even permutation. I j k, they are all different. Odd permutation and otherwise. So you can do it either maybe Python or C or C++, whatever languages you are familiar. You can write down the program and then do it on your PC. Or you can use your hand using cofactors. So another homework is such as okay, 1 0 2 0 3 4 5 6 7 8 9 10 11 12 13 14. So use cofactors. You can use find determinant A. So in general, determinant for n by n matrix best method is using Levi-Civita. I1 and this generalized Levi-Civita symbol is the same when epsilon I1 I2 In plus 1 minus 1 0 I1 all different and even odd otherwise. But during this semester, maybe we'll be just focusing on 2 by 2, occasionally 3 by 3, very rarely 4 by 4. But you have to know the general method. So you can just write a Python program to do it. Determinant A. So what do we do with those determinants in inverse? So in general, inverse matrices maybe just 10 more minutes and I'll stop. Okay? Too much material to digest today? Just one simple linear equations. A11 x1 plus A12 x2 equal P1. A21 x1 A22 x2 is P2. Say we have linear equations of 2 unknowns. And if you have 2 equations, then sometimes you can solve, sometimes you cannot. So these linear equations can be transformed into matrix equations. So this is basically A11, A12, A21, A22 times x1, x2 equals P1, P2, right? So this is called A matrix. We call this column matrices this way. P. So this is called 1 n by 1 column matrix. Or sometimes we call cat vector. Cat vector. Particular name. So when I say cat vector, that means 2 by 1 column. For this matrix, if determinant of A non-zero, what happens? Inverse exists, right? Exists. Basically, this is A11, A22 minus A12, A21 times A22 minus A12, A21, A11, right? If determinant is non-zero, then since Ax is B, we can multiply inverse on the left side. P, right? But last week, I told you that the matrix multiplication is associative. So it doesn't actually matter which order you multiply the matrix, right? So actually you can multiply this first. And this is identity, right? So this is X inverse P. So inverse matrix can be used to solve the linear equations. So say, can I continue? Or you still need time to copy? So X, which is X1, X2, is inverse times B, A11, A22 minus A21 times A22 minus A12, A21, A11, P1, P2, right? So you can just write down the answer in the following way. A22 minus A12, A21 times this, A22B1 minus A12B2 minus A21B1 plus A11B2, right? So we have the answer that X1 turns out to be A11, A22 minus A12, A21, A22B1 minus A12B2. X2 is simply A11, A22 minus A12, A21 minus A21B1 plus A11B2. So you can just solve these 2x1 linear equations in one stroke. You can double check the answer by using the method you are familiar, since you're probably middle school days, Gaussian elimination. So I will make a copy first. Copy. And delete. Next page. Paste. We have the answer, right? So this is the answer that we obtained. The Gaussian elimination, you're familiar. x1 plus a1 2 x2 b1 a21 x1 a22 x2 b2. What do? You first eliminate x2. You multiply 1 by a22 minus 2 times a12, right? This one method. Then what happens? a11, a22, x1 plus a12, a22, x2 is a22, p1, and a12, a21, x1 plus a12, a22, x2 is a12, b2. You delete, subtract this. Then this cancels each other. a11, a22 minus a12, a21, x1 is a22, b1 minus a12, b2, right? So x1 is a11, a22 minus a12, a21, a22, b1 minus a12, b2. So this answer is same as this, right? You can use the Gaussian elimination to calculate. And same for x1, x2. You can eliminate x1 as well, obtain x2, right? Same method. So the answer should be the same. So you can use it either Gaussian elimination or this inverse matrix to solve the linear equations. About 70% of the engineering problems you can change into linear equations, set of linear equations. So as an engineer, you can solve majority of the engineering problems just finding the determinant and inverse matrix. So if you know that well, you're really in good shape, because as an engineer, you have a very good tool to solve maybe majority of the problems. Perhaps we can stop here today and continue the discussion next week. Any questions? No questions? And I'm going to put my class on YouTube maybe tonight, like last week, and also PDF file as well on the website. 웹사이트 올려놓을게. All right. So see you next week. 이대로 안 가도 되고. 끝나네요. 네.
저번 주에 수업을 빠져서 그런데
네.
출석 어떻게 하나요?
네, 해줘. 네.
오늘 따로 출석 체크